and a graphing one that has a negative out in front. And so the first thing we should notice is that there's a negative out in front. And whenever we notice this, we should notice that this graph will be frowning. It's going to be frowning because of this negative out in front. Okay? The second thing we want to do is realize that this is actually a function that y equals. Okay? So if we know this is a function that y equals, then now we can deal with this as a derivative. And so we want to look at what y prime is equal to. And remember, that's that whole deal where we take the exponent times coefficient. 2 times 1 is negative 2. X, take 1 from 2, it leaves 1. And we just keep doing that. 1 times negative 5 is negative 5. But 1 from 1 is 0. Right?
Okay.
And then, and so that means there's no x left there. And then there's actually x to the 0 here. And 0 times 6 is 0. So then that just cancels it all out. So that goes away. This is your prime, right? And so what we do with that prime is we set it equal to 0 in order to find the vertex or the point of symmetry. It's where the slope is actually becoming 0. The first derivative is talking about the change in y over the change in x, or in other words, the slope. So the change in y is positive, 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 up, it's 0, and then it's negative, negative, negative. And so at that point of 0 is going to give us that one point that's right there at the top. And that's going to give us also this line of symmetry. Okay? So at first it'll give us the line of symmetry, and then it's going to lead us to the point of symmetry. Or in other words, as the book would put it, it's going to give us the vertex, or the axis of symmetry, and then it's going to give us the vertex. It'll lead us towards the vertex. So when I solve this, then I'm going to add 5 to both sides here. When I do that, I get negative 2x is equal to 5. Okay? And so now, so now when I solve for x, then I'm going to divide by a negative 2 and divide by a negative 2, and I get x is equal to 5 over negative 2. Okay?
And that's to find the axis of symmetry?
And that's to find the axis of symmetry.
Okay.
Yeah. Okay, and so the axis of symmetry, I can also say it or it's 2, negative 2 and 1/2. Does that make sense? So it's negative 2 and 1/2. And so to find out what y is, I would plug this in and solve it. Okay? So in order to solve it, I need to plug it back into y. What does y equal? Y equals negative x squared. And then minus 5x plus 6. Okay? And so my x, remember, is negative 2.5. Or if I'm going to be squaring it and stuff, let's just keep it in its regular fraction form. So negative 5 over 2. Okay? And negative 5 over 2. And so when I do this math, I get y is equal to negative, and notice how the negative's out in front? I'm not squaring that negative. The square only affects the x. It doesn't affect that negative out in front of the x. Now it does affect this negative, right? That negative that's inside there. So now it's going to say negative 5.5 times negative 5.5, and you get a positive 25 1/4. And over here, you get minus, and then a minus times a minus gives you a plus. 5 times 5 is 25/2, because this is really 5/1. And then plus 6. And I cannot add these because they're not like terms, are they? So I need to make them into like terms. So y is equal to negative 25/4 plus 50/4 plus 6. Because if I multiply this by 2/2, right, it's going to change the bottom into a 4, but the top into 50. Okay, so now I have like terms, or I have denominators that are the same, so now I can add them. Now this is a negative and this is a positive, so when I add them up, I'm going to get y is equal to 25/4, positive 25/4, right? Plus 6. And 25/4 is the same as 4 goes into 25 6 times with 1 left over, right? So y is equal to 6 1/4 plus 6. So therefore my final answer for y is 12 1/4. And so this axis of symmetry is now, has led us to find the point of symmetry, or the vertex. So now I know exactly where the vertex is. So I can graph this, right? And I can go to 2, and I'll do that in blue, right? So x, 1, 2, 3, and it's at 2.5. So it's this 2.5. Oh, sorry. It's at negative 2.5. So that's a big difference, right? Negative 2 1/2 is right here. So that's what that axis of symmetry is telling me. It's somewhere on that line. And then when I plugged it into the y to find what the y value was at that point, I found out that it's 12 1/4. So I can go along this line to 12, right? And I'll do that in, let's do that in red. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1/4, so a little bit more. And so right there is that point of symmetry. And at that point, I know that it's coming down, right? How far it comes down, I'm not sure. Like how it's coming down, I'm not sure. But I know it's frowning. So my next issue is to find some other good valued points. And on your test, it'll ask you, hey, can you find me the x-intercepts? Well, the only way to find the x-intercepts is to do the quadratic formula. Okay? They're going to tell you where it crosses the x-axis. Okay? So, let's start with the quadratic formula being negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? As long as, and that's that whole quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, right? If and only if, or whereas, ax squared plus bx plus c is equal to 0. Well, ax squared plus bx plus c is equal to 0, so therefore I can say that this is a. I'm going to use a as red, b is blue, and c is green. Okay? And so a, let's start with our b's. I always like to start with the b because it's right here, b and b. So I'm going to start with my b, and b is this negative 5. So that's going to be negative 5 and negative 5 right there. And then I'm going to plug in my a's. So my a's are red, and it's just this negative, which means what? Is it just negative, or is it negative 1? Okay? Negative 1. Okay? So, I want to make sure this is on here. Okay. So negative 1 goes where the a's are. So negative 1 and negative 1. And then I put in my c's, and my c is this plus 6. So that 6 goes right here. And so when I do this math, right away, this negative and negative makes this a positive. Plus or minus the square root of 25 minus times a minus is a plus, so plus 4 times 1 times 6, which is 24, all over 2 times negative 1, which is negative 2. And so now I have 5 plus or minus the square root of 49 all over negative 2. And I'm going to bring that up right here and say 5 plus or minus the square root of 49 all over negative 2. And then work that. What's the square root of 49?
Is it 7?
7? Yes. Okay. So now I have a plus or minus, so it's going to be separated into 2 answers, right? 2 answers. One I'm going to add 5 plus 7 divided by negative 2. And the other I'm going to subtract 5 minus 7 divided by negative 2. And so now I've got 12 divided by negative 2 and negative 2 divided by negative 2. So now I have negative 6 and negative or positive 1. Okay? So that point, or I mean the x-intercepts, x equals, when y is 0, x is negative 6. So 1, 2, 3, 4, 5, 6, and positive 1. And so now I know what my graph looks like. It comes down, and it comes down, And it looks like that.